Hey, third grade. Okay, so we are going to talk about compatible numbers for adding and subtracting. So this is probably going to be a video that you might want to keep around. I'll also share the Jamboard so that way you can kind of see my notes and print them out if you would like to. So compatible numbers are numbers that are easy. That's the big one, right? So they have to be easy for us to do mental math. So easy for us to do for mental math. So when you think about that, if you are trying to think of the answer for 76 plus 33. What the compatible numbers are going to tell you is that they are going to be friendly numbers or easy ways to solve it. So that might mean that if I subtract 1, then now all of a sudden I have 75. And if I add 2, then that would make that 35. And that's easier for me because I know that 5 and 5 is 10. And I know that 70 and 30 is going to be 100. So that would be 110. I know that then I need to take 110, subtract my 1, or add my 1 back in, which is 111. And then I need to subtract the 2 that I added, and that would get me 109. So 76 plus 33 would equal 109. That is a very quick example for compatible numbers. And now I'm going to break it down for you for each step. Okay, so one of the first ways to do compatible numbers would be related facts. So let's say something like doubles. So we know that our doubles are going to be the same thing, like 2 of something, right? So kind of matching pairs. So we have our doubles like 2 plus 2 equals 4. And we have 4 plus 4 equals 8, and 8 plus 8 equals 16. Or maybe you would have 3 plus 3 equals 6, and 6 plus 6 equals 12, and 12 plus 12 is 24. So you might want to use different doubles to get yourself where you might need to go. So for instance, if we, one second. Okay, so if you think back to the problem that we were just doing, 76 plus 33, you could use doubles to help you figure out what we need to do here. So I know that 6 is actually 3 plus 3. And so if that's 3, we could do our doubles that way and try to break down the numbers so you could see what is going to equal what. The other way that you could do it is by looking at how you could use the doubles to make these numbers easier. So for 7, I know that 7 is 6 plus 1. Actually, it's 60 plus 10. So 70 is 60 plus 10. And I know that to get 60, I'm going to use my doubles, which would be 30 plus 30. So 30 plus 30 plus 10 is going to be 70, right? Well, 30 plus 30 plus 30 is going to equal 90. And then I need to add in my other 10, which is going to equal 100. And then I know then that I have my 6 and my 3. Well, I know that 6 plus 3 is actually 3 plus 3 plus 3, which is going to equal 9. So 100 plus 9 equals 109. So that might be another way that you try and solve that problem. There's a couple of other different things that you could do to try and tackle it with your doubles or related facts that might work out. But for right now, we're going to stick there and move on to the next idea. So your benchmark numbers are going to be kind of your numbers of where you can have your starting point. So a lot of times you might see benchmark numbers used for like number lines or kind of just like your starting off points. Or maybe it would be like, well, I know if I add this much, I would be at 10, right? So let's stick with the same addition problem that we've been doing, that 76 plus 33. So if I'm going to do my compatible numbers with a number line, just to give you an idea, what I would know is that if I started at 76, well, I know that if I add 4, that would give me 10, right? 6 plus 4 is going to equal 10. Well, so my benchmark number, then if I added 4, I know that would get me to 80. So that would be kind of like a benchmark number. What can I get to 80 or to the 0? So then I would know that, so that is plus 4. So I would subtract my 4 from that one, which is a little bit more. So now I'm at 29, right? Because I went a little bit more than 33. So if I added 30 now, if I added 30, that would be 80. That would be 80, 90, 100, and then 110. But I know that I went 1 over, right? So I need to go backwards 1 more. So I need to take away that 1 extra from the 4 that I was over, take away a negative 1, and that would put me at 109. So what that would look like if you were going to add it instead of using the number line. So what you could see, if we just used it like an equation, you could do like 70 plus 6 and then 30 plus 3. Well, so I know that 70 plus 30 is going to get me 100. And then I know that 6 plus 3, well, I'm not quite sure. But if I add 1 more to that and get 4, I know that 6 plus 4 equals 10. Or I also probably could have done 7 plus 3 equals 10 if I wanted to do it that way. But either way, I had to add 1 to one of those sides. So then when I add those together, when I add my 100 and my 10, I get 110. But I now have to get rid of the 1 that I added to make 4. And now I'm at 109. Okay. So another way to do it would be to do it with a 5 ending in 5s. And so what I want to show you with that one, so I'll go ahead and I'll do that one up here. So if we had 76 plus 33, well, I know that if I take away 1, that would be at 75 plus, and then I want to add the 2 here, and that would give me 35. So when you're looking at that kind of a question, I know that 5 and 5 is 10, and I know that 70 and 30 is 100. So that equals 110. And now I need to subtract and add my 2 and my 1. So 110 minus 2 is 108. And 108 plus 1 equals 109. So that's kind of how the benchmark numbers would work. So making 10 is also kind of using those benchmark numbers with ending in 0. But making 10 is you're just going to try and figure out the best way that you can solve your problem by using making 10. Well, if I know that if I add this, I'll be 10, and that's one more, and I'll go backwards, kind of like what we were talking about. This time I'm going to use a different number so that way you get a little bit more experience. Okay, so if I wanted to use the making 10 for compatible numbers in order to solve a problem like this one, this is kind of what it would look like. So what I would notice is that 8 and 3 and then 4. Okay, well, I know if I can make 10, I know that 7 plus 3 equals 10, or 6 plus 4 is going to equal 10, or 8 plus 2 equals 10. So looking at that, if I subtracted 1 from my 3 here, then I would have 8 plus 2 equals 10. So I've added those numbers. And then 10 plus 4 is going to equal 14. But then I have to make sure that I go ahead and I add 1 to get my 15 because I subtracted 1 up there. So then now I can go ahead and move on. So I know that, again, 70 plus 30 is going to equal 100. So if I took my 20 and I add 10 to that, I would get 30. And so then I would have 70 here, and 70 plus 30 is going to equal 100. But then I need to subtract my 10 out of that. So minus 10. And that would get me 90. And then I also have this 10 right here that I could have just left alone. So I could have just added that 10 here to my 20. So then I wouldn't have even needed to erase that if I would have just been paying attention while I was teaching. I wouldn't have even needed to do that because I could have just added that 10 right there. So this 10 that came from my 13, I'm going to go ahead and add it to my 20 to get 30. So then we're at 100. And then I have 100 left to add. So I have 100 plus 100 plus 15 is going to equal 215. Oh, I just erased that. So it equals 215. So you're making 10 is where you're going to mix and match and use what you know about making 10 or making hundreds. Again, kind of like the same thing that we were doing with making it the 0. You just want to be able to see what you can combine. The biggest thing about compatible numbers is that whatever you're shifting, in order to make things friendly, that we have to put them back. And so, like, for instance, when you're working with a number like 76 plus 66, if we're trying to solve this problem, you can use compatible numbers to help you. Like, if I subtract 1, I'm going to get 75. And if I subtract 1 here, I'll get 65. So 75 plus 65, well, that's going to be 10 and then 140. Well, in order to actually get the actual number, then what I'm going to need to do is I have to add the 2 that I took away back in. So that would mean that I need to add those to my 140. So it's actually 142 is my answer. Now, compatible numbers are very different from estimating and rounding. So rounding is going to get you to the nearest tens or to the nearest hundreds or whatever, but we're going to go up and down. And so I want to show you what that would actually mean. So if I was going to round, so this right here is compatible. But now, if I wanted to show you what estimating or rounding would be. So if we were going to round 76 plus 66 to estimate, what we would get then is we would round 76 to 80, and 66 would then go up to 70. And so our answer would be 150. But that would be it. That would be all that we do, because estimating is just a guess. Compatible numbers is the way that we change the numbers to make them easy to actually get the solution. All right, we will work on more of that when we come together.